Hey everyone. So today I want to go over how to model dock structures. And so this is a typical dock structure that we have. I mean, it is a big one, but I mean, it is a pretty typical system that we have here. So just looking at the photos, a little bit hard to tell, but generally, let me zoom over here. We have a series of piles going vertical in the structure. We have, I guess you call it girder beams going on top of those piles. And then we have a series of joists or stringers on top of those that go the opposite direction. So you can see some girders right here, girders in this location, girders down here, and there's another girder over here. And then the last part is over top or underneath our walls, we actually put steel tubing, and not necessarily something, well, definitely not something that we came up with, but it's been kind of an industry standard for a number of years. And what this has allowed dock builders and our clients to do is over time, as the dock boards rot, because it's usually the first thing that'll fail on a boathouse, they aren't going under the walls, and it kind of gives some structure and some longevity to the building itself. And so that's a general overview of how we model it, or what we're modeling. One thing we're not going to model today is these cross braces. And just to kind of give credit where credit is due, we're working with an engineer, Deconing Group. They're based out of Port Carling, and this dock was built by Brown Steel Docks. So just want to kind of give a shout out to those individuals, and then our general contractor on this project is Napier Valley Construction. So just this is not necessarily our work per se. So we are the designers of the building itself, but we have a team of people that kind of bring a lot of this together. So just to talk about modeling of the structure. So I've just got a blank project open here, and what I usually start off with doing, and we kind of have this built into our template, is we actually drop a level down. We drop it down, is it 15 inches, I believe? I'll check that in a second. So, sorry, it's 1 foot 3. And we'll just call this top of piles. And so essentially what this datum is going to be, it's going to be the top of our columns going in the water. We'll often just model another one down below. So I can just drop this one, let's just say 20 feet down, and we'll just call this bottom of piles. In our template, we often have our bottom of footing, and we'll just keep that in our file and use that as that element to model. So let's start doing some modeling, and when we start off, we want to bring in some column types. So if we don't have them, typically we use a steel pile that's somewhere around 5 or 6 inches. So we're going to go to Load Autodesk Families. I'm just going to verify I'm in Imperial. Let's move that to Imperial. We're going to go down to Structural Columns. We want to do round HSS right there. So let's bring that in. And it's going to ask us what sizes we want to bring in. Generally, most columns are around 6 inches, 5.5, 6 inches. So we can bring in a 5.5 by, it's actually, we use a pretty thick one. So 5.5 by 1/2 or 5.5 by 5/8. So they just use really thick columns for dock structures. It just helps longevity. They often will use 6s, 7s, or 8s, depending on, I guess it looks like 8/6. And this is very much dependent on the, right here, that one there, the depth of the dock structure. So depending on the depth of dock structure, where we have like 20 feet depth, they'll probably stick around a 5 or 6 inch column. If we have, 100 feet deep, which is quite possible in the water in various locations, we want to potentially increase the diameter. So I'll start with just our 5 by 1/2 columns. And so I'm just going to place one here and just kind of show you what's going to happen. So this is, you're going to see anything. And there's a few different ways to fix this. Probably the best way from a drawing perspective is to turn on underlay. We want to turn it off after. So base level is that, so that's not showing. You just see that's going to show. No, it's not. The underlay won't work because we haven't set that other part up as a level. The other way of doing this is we can bring in a plan region. The reason why I like to do this sometimes is it doesn't override the file, and then you can visually see that you change this piece. So we can just take our view range and we can take this down to negative, let's go negative 2 feet. And we're going to change the view depth here as well. And so now we can see our steel column. And so again, we work with engineers on these types of structures, but generally all of our docks are placed in grids. So I'm just going to go 12 feet by 12 feet. And let me just show you in 3D what we got going on here. So we have these 4 kind of steel piles here. And so in basic form, you know, what we want to do next is we want to bring in our beams. And so we're going to bring in a series of beams here. We want to bring in wide flange beams. So we want to go into structural framing. We want to find a wide W wide flange right here. And typically for most dock structures, we use 6 by 25s, so very small. And we kind of, as you saw with that photo, we bring it's a pretty beefy structure, so we don't need a ton. So we bring in 6 by 25s and 6 by 15s. That's really all we need for W. And then let's go to load in again, and we need to bring in some C channels. Oh, wrong button. Load in, we'll bring in some C channels. So C shapes, actually let's bring in the C channel. And we want to bring in a C 6 by 8.2. And that's used in a few spots. And then last thing we need to bring in is a HSS tubular steel piece. So HSS rectangular, bring in one of those. And we want a 3 by 5, I believe, 3 by 3, no, 3, where did it go? 3 by 5, or 5 by 3, 5 by 3. So 5 by 3 by a quarter, let's bring in the 1. And so now let's start to model. So let's go to our structure, let's go to beam. And we want to model our girders. So our girders are going to be our 6 by 25s. And we want to line those up with our columns. And I'm just going to extend them past like so. We can copy this over. And so you can start to see we've got some structure happening. So these 6 by 25s, they are 6 inches above our, let's edit our work plane here. These are 6 inches above our top of piles. And then all of our piles, they go up to top of piles. So let's just change that to top of piles. Let's change our bottom to bottom of piles and make that 0. So you can see we have something that looks like that. And then the last kind of part of this, we can change this to fine view so we can see our piece. The last part is we do a beam system typically, and this kind of takes care of a lot of the dock structure. So we'll do something like that. And I'm just going to turn off tag members and go to none. Just going to delete these tags because it's just not necessary to tag all this stuff. And when we model this, we mostly do it from a coordination perspective. So this we want to be -3 inches. So it's sitting 3 inches below, and I'll show you why in a second, but it's sitting 3 inches below. Generally, these are at 32-inch centers, and generally we actually use the smaller ones. So if we use a 5/4 material like Ipe or even 5/4 pressure treated, we just need to take this spacing down to 24 inches instead of 32 inches. So that's generally how we model a dock. So just some complexity here. So say for example, we had a wall in a location. What we'd want to do, whether it's perpendicular or parallel, we would want to model that C channel on top, or sorry, the HSS on top. So often the engineer will put that HSS on top of the the girders underneath just to make sure that load carries down neatly, but if it's not, they often block it. So one thing I usually start by doing is I go in here and I just change the width and I flip the width and the length. So I make this 3, make that 3, the width is 3, 5, and then the height is 3. And that way it goes like that. And then that would be where the wall, that would be placed under the walls, and it would actually stop and break at the different openings. So kind of that's how that works. And so just to give one more scenario on complexity, say for example, we had a boat slip over here. So let me just maybe draw this in this beam system. We have a boat slip. Boat slips are typically 10 feet wide. And this one's, we're just gonna make this one not very long. And we usually have some sort of angled piece. Normally I would do this on a really accurate, actually, you know what, let's make it a little bit more accurate. I'm just gonna mirror this piece. And so this is what the boat slip would look like. And so we start by just using the beam system to kind of outline this. And we'll break this piece here. And let's fill it that, and fill it that. Broke the wrong piece there, but it's okay, it still worked out. And so when we click our check mark, it's going to have our pieces kind of going around that dock like that. Depending on what's going on, we might need to make some other adjustments. Like if this member isn't right on the edge of that, actually let me put some dash lines in here. I'm just going to copy these lines, and I'm just going to go to annotate filled region, and I'm just going to make this crosshatch transparent, paste those lines. So that's our dock there. So now if we go to our structural steel, if these members aren't right on the edge, we might need to physically model that. And what I often do, just for simplicity's sake, is I'll grab a beam, and instead of modeling like we just did, I'll use the pick line, and I'll offset that by 3 inches. Let me see here. We could go to Y offset value and make that 3 inches. And when we pick this, it's not offsetting. I'll fix that in a second. And so now we can just kind of go around that slip area. And this piece right here, we would want to unpin it, and we would just bring it back. Usually after I set up the beam system, we'll delete it, and just keep all the members. So you can tab over the beam system here. We can go to remove beam system, and we'll keep all the beams in place, but removes that system per se there. So that's generally how we set up the dock. And then the last thing we just need to do is these need to go down the 3 inches that we did before. Shift that one, so this will go down -3, and that's at the same level now. This would actually be down -3 as well. And oh wait, actually no, it's not down -3, it's 0, because that's sitting right on top of the steel like that. So that's how we model a dock. And so it's very different on every project, but that's the general layout. And when we get the engineering, you just follow and put the beams and place the beams exactly where the engineer wants it. So let me know if you have any questions with that, but that's how we typically model dock structures. Maybe one caveat, actually, I'm going to mention one more thing before I finish, is, sometimes we have this tubular steel going parallel like this, or, something like this. And what we might do, which is why we brought in that C channel, is we would put that C channel on either side, and that's just to pick up the dock boards like so. So we put that C channel on either side like that. And we just got to make that -3 inches, and that's how we get the dock boards to sit next to the wall like that, like so. Yeah. So that's it for docks. That's kind of how we model stuff. Use the beam system to do a lot of the modeling, and then remove the beam system, and then you can make some adjustments based on what's in the engineering after. So hopefully that helps. Let me know if there's questions.